Next, we're going to transition from looking at the reduction of aldehydes and ketones to the reduction of other carbonyl containing functional groups like carboxylic acids, acid chlorides, esters, and amides. But before we do that, I want to talk a little bit about the difference between these two classes of carbonyl compounds, and that's going to play an important role in the reactions that we talk about. So if you look at the aldehydes and ketones, these kind of form a class by themselves because on the carbonyl compound you have attached carbons or hydrogen. So on the carbonyl there's no leaving group attached. So what that means is if you add a nucleophile to one of these, like a hydride, it can only add once. So let me show you an example. If you take a ketone, and we'll keep it very generic right now and add Nu-, if we add that to the carbonyl, there's no leaving group on this carbon right here. So that means we're stuck at this tetrahedral intermediate until you protonate the oxygen. Now let's look at our other class of carbonyl compounds. This includes the carboxylic acid and the other three which are considered derivatives of carboxylic acid. In a later chapter, we're going to talk about exactly why these are considered derivatives of a carboxylic acid. The difference with these is the fact that if you look at what's attached to the carbonyl, we have atoms that are a bit more electronegative, like oxygen, a halogen, oxygen, and a nitrogen. These are considered leaving groups on the carbonyl. Now, I will mention in the case of the amide, we're going to find this really isn't a very good leaving group. But under the right circumstances, it can act as a leaving group. Whereas with aldehydes and ketones, carbon and hydrogen, it's not going to happen. What this means for the reaction is a nucleophile can add twice. So let me demonstrate this for you. So let's say we have, I'll just do an acid chloride because that's the best leaving group of the bunch. If you add a nucleophile to this, just like with an aldehyde or ketone, it's going to add to the carbonyl. But now we're not stuck at this tetrahedral intermediate. Instead, what's going to happen is this negative charge, those electrons will come back down, and you'll lose the leaving group. From there, we've reformed a carbonyl compound, and then the nucleophile can add to this carbonyl. And now we're stuck. So you don't get stuck at a final tetrahedral intermediate until two nucleophiles have been added. So that's the big difference in aldehydes and ketones versus carboxylic acid derivatives.